Yeah, day 3, but I hope it feels still energizing with all the conversation about agents and whatnot. I hope you have enjoyed it. It would be remiss if we don't have one more agent-related conversation today, right? So that's what we're going to talk about. We'll talk about securing AI agents from development to runtime. So there is a lot that's going on, of course, in this space, and we realize that one of the biggest hurdles in enterprise scale adoption of agents is security. And we have had a number of sessions about that already, but we're going to go one level deeper into some of the areas of that. So for this conversation, I'm going to be joined with Knox Anderson. He leads a number of things related to securing AI at Google Cloud, and Kishor Patil, who is the Senior Engineering Manager at Best Buy. He'll be sharing with us Best Buy's journey as they adopt AI agents. And myself, Ravi Shah, I am the PM lead for all things related to identity at Google Cloud. That includes human identities. Until last year, that was just human identities and non-human identities or workload identities. But this year, of course, that includes agent identities as well. So that's my remit, and we'll talk about a bunch of those areas today. So what's on the agenda? We'll talk about agent security challenges. We'll talk about securing development. We'll talk about hardening agent operations. And then how do we put it in practice? How do we see it come to life at Best Buy? So that's the run of the session, if you will. But let's start by talking about how did we get here? I'm sure each one of you kind of remembers where you were at the time, like late 2022, ChatGPT launches, everybody is just talking about it. That was the time when LLMs were basically nothing but autocomplete machines, right? You type something and it will come up with the next thing based on whatever it has been trained on. And the result of that was basically that the LLMs were hallucinating big time, right? Remember those times? Now, as the time progressed, the industry realized that that's a problem. So LLMs were transformed into these reasoning machines. So all I would do is think before responding. Hallucination went down, not eliminated, but at least went down, right? That was kind of the second phase, second era in this fast-moving world right now. And then LLMs actually got more and more transformed into brains that are driving the agents who are actually orchestrating the entire flow. That brought in a lot of determinism in the flow as well, but the LLMs were the real brains who were powering these agents. And of course, we have all realized the power of agents with this framework, and that has led to today, where agents have really become a rage. We want to see how agents can help us all become productive, how agents can really help us scale our operations, and do things that we didn't imagine we would be able to do in just a few years back. But of course, with all this possibility, there is a lot of responsibility that we have as well. And we see that sort of across all these use cases, each of these use cases, while they promise a lot of potential, there's a lot of hesitation as well in terms of deploying it at full scale. But let's run through this. Right? There are a number of high traction use cases, whether it's in coding or in customer support. There are a number of them which are in like sales and marketing kind of area, which are growing fast. And then there are a number of use cases which are emerging, like legal and compliance reviews, so on and so forth. But quite honestly, and I said this in one of the earlier sessions as well, this is the slide that I put together maybe last week, and it's probably already obsolete, right? You have new use cases that you would have thought of just this week, and they will gain a lot of traction. So there's a lot of fast movement in this area, yet I think we're not maybe all that comfortable yet with the security and governance. So we want to make sure that we lay the right foundations in terms of security and governance of these agents. So before we jump in furthermore, we want to break it down a little bit. Break down the life of a typical agentic deployment. And I'm sure there are other patterns out there as well, other environments where you would run as well. But this is kind of like a big picture view. A developer comes in, they will build the agent using whatever tool chains or frameworks you want to use, whether it's ADK or something else. You will have an agent. The agent will need to discover other agents, other tools. So there's a discovery part. When it's deployed and it's running on agent runtime, at runtime, it will need to retrieve credentials, for example, to talk to a tool, to talk to another agent, to talk to another API service, right? And then as it does things across the LLMs or other agents, there are different protocols that it will have to follow. We provide a MCP layer on top of all our services, but of course, everybody else is doing that as well. And as we sort of put this entire life cycle in perspective, we see that an agent has to operate in this very broad orbit, if you will. The agent would be talking to other models via REST APIs and HTTP and whatnot. Agent would be talking to other tools via MCP. Agent would be talking to APIs over HTTP. And agents would be talking to other agents over A2A. So if you think about it, this diversity of modes in which the agent has to operate brings in some very, very interesting challenges. It's pretty broad, but it's our job to make sure that the agent stays in orbit. What does that mean for the agent to stay in orbit? Number one, we have to make sure that the agent can be very clearly identified. Nobody should be able to impersonate that agent. And whenever an agent does a task, we should be able to say, actually, an agent did the job, and this is the particular agent that did the job. This is very foundational, but a very important and big challenge in the agentic world. Number two, even though you have defined sort of the boundary, within the boundary itself, we have to make sure that the agent is operating with least privilege so that it doesn't do anything more than it should, so that it stays sort of within the lanes and doesn't try and access something or release some information that it should not. And last but not the least, it has to absolutely keep the data within its orbit. It should not be that wrong pieces of data get out of this orbit or wrong pieces of data come into the orbit. Both can have unintended impact on your operations. So it's very, very important that we keep the agents in their orbit with these sort of constraints, if you will. Now, with all of this in mind, I'm sure you all heard about the Gemini Enterprise Agent platform that we have released. We have a series of capabilities around the build area, series of capabilities around how do you scale, series of capabilities around governing these agents and optimizing the performance of these agents. But today, we're going to, right now, just going to focus on the governance side of it, security side of things, making sure that you have the right set of tools for that. We believe that in that chain, that there are a number of things that need to be done. One of the first things that we have done is that providing you with a gateway that controls what are the ingress operations that can happen on the agent, what are the other agents or tools that this agent can access. That is where registry helps. Identity and access management is a key part, making sure that the agents have the right identity, but also the right access management policies. We have Model Armor, which makes sure that there is content protection in terms of LLMs, what content can go in, what content can go out. We have natural language support, and we also provide you with service extensions so that this gateway can be extended with a custom set of capabilities that you may need. With all of this, we provide you sort of the framework for having strong governance around your agents. So with this foundation in place, I'll invite my colleague Knox on stage to talk about all these components in more detail.
Thanks, Ravi. And thanks, everyone, for making it out to an 8:30 session. We really appreciate you all being here. I'm Knox Anderson. I work on model armor, sensitive data protection, and SEC, and cover kind of the full agentic lifecycle. So let's dive deeper into secure agent development. Secure production deployments start with secure development practices. And so similar to normal software development, you need to make sure that you have a secure supply chain. Second, many of us talk about evals for quality and reliability and cost, but they're all equally important to security as well. And then I'll get deeper into governance and the agent registry on how you can discover the different tools, agents, and skills that are deployed in your environment to make sure that you have proper policy and governance of everything that's deployed. From a supply chain perspective, sadly, we're making the same mistakes that we did with open source, where it's super easy to pull down an NPM package from a registry that's malicious. We're seeing the same type of thing happening in the wild with skills. I'm sure everyone in this room has played with Claudebot, Moltbot, and we're already seeing over 15% of skills that are pushed to public marketplaces being known malicious. So really, we need to take the same things that we've learned from a CI/CD perspective and a supply chain perspective and apply those best practices to agents. So restrict ingestion to known trusted sources, sign your skills, verify those, perform static and dynamic vulnerability scanning against all your agent manifests, skill manifests, and then most importantly, if you've been following the light LLM breach, the Trivy breach, everything that's been happening, pin these dependencies. I see too many different build practices where you're just dynamically pulling in dependencies, dynamically pulling in skills. Make sure to pin your dependencies because I think, at least in the open source ecosystem, we'll see more and more supply chain attacks happening. People often talk about evals in terms of quality. Does my agent answer like I'd expect? Is that answer correct? But the same lens can be applied from a security perspective. If I prompt my agent to reveal sensitive information, will it do that? If I prompt my agent to generate harmful content, will it do that? We've added a native eval service to the Gemini Enterprise Agent platform that is a fully managed service that can be used to run quality and safety evals online or offline against your entire environment. So let's take a little bit of a deeper look into how this works. Starting with the left, you can see your evaluation input, where you have two different types of things that you can send into this eval harness. Traces, which capture the internal reasoning, tool calls, and API parameters of the agent, and then sessions, which represent the full multi-turn conversation that happens with the user. These inputs feed into our configuration layer, where the ideal outcomes are set. So you can have metrics such as groundedness or helpfulness, and then golden traces, which represent the ideal behavior that you want your agent to follow. The central engine here is our evaluation service, where you can bring your own judge model that's a flashlight model or something like that, where you have your own prompt that looks for what you want to expect in that known good set from your agent. The resulting output then allows us to categorize behavior, so you can see risky responses, safe responses, and then have a full closed loop system to make sure your prompts are meeting the metrics and the golden standards that you've set for your different environments. And then last, we'll cover the agent registry. This is a little bit of a mix of build time and runtime environment, but as we move to multi-agent architectures, it's going to be more important for the developers that you have to be able to discover what other agents are available in the ecosystem, what tools are getting the most adoption across your environment, and then have visibility into what's deployed. Beneath every agent is a capable set of tools, and so our agent registry provides centralized discovery of these tools, preventing redundant development by allowing teams to reuse those different capabilities. And then most importantly, from a security perspective, is the direct integration with policy. The registry allows you to have granular governance around which agents can be used in your environment based on its registration status, specific tool characteristics, or metadata tags like this agent is only approved for internal use, or this agent has been verified to be able to process PII data. So all of these policies can be managed as part of your agent registry and then is hooked into Gemini Enterprise, Agent Engine, and a lot of the other services that are deployed onto GCP. So moving past from runtime, let's dive deeper into how you secure your agents as they're deployed into production. First, all agents need to have a verifiable agent identity. Second, all prompts and responses should be scanned to make sure that you're not leaking sensitive data, there's no indirect or direct prompt injection. And then like any cloud workload, you need to monitor that runtime behavior for anomalous activity, vulnerable dependencies that may be pulled in, any threats, and then make sure that's hardened from a misconfiguration perspective. We're really excited to announce all of Ravi's hard work over the past year with the GA of Agent Identity. It's a new first-class identity in the GCP ecosystem that's fully integrated. The thing I'm most excited about is if you're using services like Agent Engine, it's fully lifecycle managed. So as soon as that Agent Engine instance comes up, it's assigned a unique identity. And then as soon as that agent instance goes away, that identity no longer exists. This reduces a lot of the things that we've seen in the past with dormant service accounts or things that should have just lived too long. And this is built into the platform natively to prevent those types of things. Second, you can delegate access so the agent can act on behalf of a human, really easing the operations of deploying agents into your environment. And then the best thing here is all of the existing policies that you know and love from GCP are supported with agent identity as well. So things like VPCSC, context-aware access, IAM, and other policy systems integrate natively with agent identity. It's also referenceable in all traces and logs, so it's easy to tie back any action that happens across the platform to that unique identity that has been generated for the agent. I'm sure you've been in many sessions this week where the gateway has also been mentioned, and this is a critical control plane point for all ingress, so client activity that is invoke agentic flows, and then egress from agents to other agents, agents to tools, agents to API endpoints that you might have on or off GCP, and that agent gateway provides that centralized point for you to bring in policy, tools like Model Armor, observability, and many of these are included by default or enabled by default to make sure that you're getting the visibility that you need in your environment. With things like a gateway, the first question we always get from customers is, how do I extend this to work with the existing tools I have in my environment? So we're happy to also announce a lot of the native integrations from tools like Palo Alto, CrowdStrike to provide content inspection, and then also with IGA products like Okta to natively bring that in via service extension as well. This is where you can also define your own custom policy callouts. So if you're using things like sensitive data protection, you can call that natively. Model Armor is another thing that's available here. And then you can bring in your own access control based on data classifications that are happening through service extensions. Every action taken by these extensions is also captured with a full trace ID. So you have traceability of the specific request, the service extension, how it was verified, and any callouts that have happened in that environment. Next, I'll get a little bit deeper into Model Armor. So from a visibility perspective and integration perspective, our goal is to have Model Armor in front of any AI or agentic interaction that's happening across GCP. So from an API perspective, having a native integration with things like Apogee for policy callout, and at the application layer, any Gemini enterprise user can natively integrate Model Armor as part of prompt and response flows within the platform. Model Armor is also included for free as part of Gemini Enterprise as a base level protection. From an inference layer perspective, you can have Model Armor enforced inline for any Vertex call or GKE inference gateway, and then at the network layer with service extensions. We're also excited to announce a bunch of new native integrations as well. So if you've been in some of the MCP server sessions, Model Armor is natively included with any MCP interaction. So if you're querying something like BigQuery via an MCP server and there's sensitive data policies that you want to put in place, that's something that you can orchestrate at the org level, the project level, and any MCP that's deployed in your environment. We also introduced the native LangChain integration. So if you're building LangChain agents and you want to integrate through a runnable, all prompts and responses can be screened at the SDK level from an agent, whether it's deployed on GCP, off GCP, it's on a managed runtime like GKE, integrating directly with the client. And then other products like Firebase as well have added Model Armor integrations as part of the features that were released at Next. So now that we've covered all the different paths, let's get a little bit deeper into what Model Armor actually protects against. So from a prompt injection perspective, screening indirect or direct content. So if your agent is summarizing things like email, we have classifiers that are purposely trained to look at email content, calendar content. That's where we're seeing a lot of indirect prompt injection in the wild, as well as MCP traffic and other things as well. The other big use case we hear a lot from customers is, hey, I have an externally facing agent. It has access to my support portal. How do I prevent sensitive data from being returned from those agents? So sensitive data protection is also something that's embedded within Model Armor, so you can define your own custom classifiers of what's a specific account ID for your org or sensitive data for your org, and then there's 200 plus out-of-the-box info types that cover many jurisdictions, PII content, and those different areas. Another thing that's important to all companies with brand is I don't want my agents having harmful content, hate speech, those types of things. Responsible AI is also included as part of Model Armor. And then malicious URL scanning, antivirus, those types of other products from Google are natively integrated as well. We have a discussion later today at 11, and one of the areas we're also looking at feedback is what custom classifiers you might want to integrate that then we can orchestrate across your environment. So if there's specific guardrails that you want to build and integrate into Model Armor, we'd love to hear from you into that session later today at 11. Moving to Security Command Center, one of the other big goals of this week is how do we take all of these security capabilities that are introduced across GCP and then provide visibility at the org level. Many GCP services are project aware, and so one of the advantages we have with Security Command Center is I can see all vulnerabilities from all agents across my org. I can see any threats, all of those different things from an org project or any layer of the GCP hierarchy. I'm really excited also about some of the threat detection capabilities that we've introduced where we have native sensors that are installed in your underlying agent engine runtime that look for things like reverse shells, malicious commands, connections to suspicious IPs. And this type of detection will get more and more important as agents have code gen use cases, computer use, things like that, where you need to really monitor that runtime behavior of the agents that's deployed. We also have a bunch of new threat detections that are integrated at the control plane level. So audit log-based detections that support Gemini Enterprise, Vertex, Agent Engine from a comprehensive signal perspective. Under the hood, many of these managed agent services in GCP are built on top of containers. And so one of the things that we also have introduced is the ability to scan your Agent Engine instances automatically for vulnerabilities. From a vuln perspective, we'll see all libraries that you introduced on top of the base image provided by Google, and then show those vulns natively to you as part of that Agent Engine instance. This happens under the hood with just a single activation. So from an onboarding and enablement perspective, all you need to do is enable SEC at the project or org level, and then every agent will be automatically scanned for vulns, and all threat detections will be applied. If anyone in the room has also used IAM Recommender and all the different policy sides, we've also extended that to support agents and agent IAM and agent identity as a first-class citizen. I think everyone is always going through an IAM right-sizing exercise. We're going to have to do the same things with agents, and so we want to make that easy as possible. And then from a compliance perspective, we've introduced a bunch of new controls to make sure that you're hardening both your Agent Engine control plane environment and the individual workloads that are deployed. And while it's great that all of these are in SEC, most of your users are not security people, and they're going to be going into the agent platform, into Agent Builder. And so everything in SEC, we're also introducing in context as part of the agent platform. So there's a security dashboard that lives within that interface that makes it easy for a developer who's deploying an agent to see if it has vulnerabilities, if there's too many permissions granted to that agent, if it's connected to a bucket and that bucket isn't encrypted. So all of that context we also show natively into the Gemini Enterprise Agent Platform. One of the other big announcements this week is something that we call SEC Standard 2.0, where we've turned on SEC by default for the top 50 to 75,000 GCP orgs. And so there's a bunch of new security capabilities that are for free and enabled as part of SEC standard. So when you go into something like this agent security dashboard within Gemini Enterprise Agent Platform, you're able to see all of these things without having to be a paying SEC customer. So with that, I'd love to welcome Ravi and Kishor back to the stage to go deeper into how Best Buy has been bringing this into production. And then, Kishor, do you want to do a quick intro?
Yeah. So myself, Kishor Patil. I'm a senior engineering manager at Best Buy. So a bit about my team is like I lead a discovery team at Best Buy, and what we do is like we do an evaluation of all the Google services from a networking, from a security, and from a feasibility standpoint. And the basic questions we ask is whether the service is feasible enough and like from a security, and it can be scaled at the enterprise grade. And once we have those answers, we create the automation for that. So we build a platform around it so that our end users, they don't have to worry about the underlying details, and that's how our platform works.
Fantastic. Thank you, Kishore, for sharing that. Of course, we are seeing sort of agentic use cases everywhere, but it's a question for us as well. Like, why agents for Best Buy? Why did you think it became sort of a necessity and inevitable thing for your organization?
Sure. So agents are everywhere, and everyone wants to onboard this agentic journey. And we were not the exception to that. We also wanted that agent environment within Best Buy. But like, we didn't use AI agents because of hype. It was majorly because our traditional systems were kind of getting too complex and very difficult to modify, difficult to maintain. That was one of the reasons. The next was, so if you see the trend, right, now the work is getting shifted from answering questions to making decisions at real time. And the customer interactions are now end-to-end journeys. For example, like in the past, customer used to say, I need a 100-inch TV or maybe a laptop or iPad. Nowadays, the intent is like customer comes up and like, I need a birthday gift for my kid. So there is a reply to that is like, is it a boy or a girl? Or what kind of interest it has and hobbies. Based on that, there is an interaction, and we eventually land up on the product. So this whole interaction, right, the reasoning behind it, the context behind it, so there is a decision making across multiple systems. So that was difficult to handle with our traditional systems. So this is the reason like agents were like become necessity for us.
Mm-hmm. That's interesting.
And so Agent Engine is a relatively new service. Tell me about your journey of what you were doing with agents before Agent Engine and then your migration to Agent Engine.
Sure. So it was not a perfect journey for us. It was a bumpy ride. And frankly, we faced a lot of problems around it. While agents were gaining a lot of traction in the industry, we also got a high demand that, OK, we need agents. Our users wanted agents in our environment. But we didn't have the required infrastructure or required security guardrails around it. So as I told you about my discovery process, right? So we were doing that discovery. So this was a situation. I always like to give analogies around the stories. So let me explain you this with one of the stories, like a sports analogy. For example, everyone knows here tennis and pickleball? Probably yes, right? So tennis is like a traditional system. It's a well-known system, right? Different rules. And we had like courts available for tennis with proper fence, with proper security. And our players, right, they used to play tennis. Everything was going good. But suddenly, pickleball emerged. And it was easy to learn, and everyone wanted to play pickleball. But we didn't have pickleball courts available. So what we did was like, OK, we didn't want our users to stop playing the pickleball. We wanted them to play pickleball, but we don't want to hold them back. So what we did was like, we asked them to play pickleball on the tennis court with certain tapes around the lines and all. So and they started playing the pickleball, and everything was going great. Like, they were learning the new shots, they were learning the rules, and in parallel, we were building our pickleball courts. And once everything was ready, we migrated them from tennis courts to the pickleball courts. And the journey was smooth, and they were able to get going as quick as possible. So that was a good thing. So now coming to the reality, what we did was we started our journey with Cloud Run and Cloud SQL. Cloud Run for deploying our models, and Cloud SQL for memory management. So, and we had a lot of security and platform-related controls around these services. So this was how we started as a tactical approach. And during that, we were building the agent engine and the memory bank. And once we had everything ready around the agentic environment, then we migrated our agents from Cloud Run to agent engine. And because it was kind of a migration, not a rewrite kind of a thing, so it was smooth. So that's how our journey went through. And now the amount of services you guys have published, right, it'll further enhance it.
That's great. That's a great analogy. I think it will stick in our minds for a long time to see how this journey is going. So I'm sure, as you transition, right, security was top of your mind. What are the different things that came up as you started developing agents? What considerations you had, and how did you go after it?
Sure. So there were multiple considerations. One of the considerations was I would like to highlight is the centralized place for the agents. So we wanted to have a place where all the agents, with their intent, with their usage, with their permission model, we wanted those agents to be registered at one place so that we keep track of everything. And so that was one of the things. And we used Cloud SQL and some of the existing toolings for this maintenance. And the next was the least privilege. Obviously, we differentiated the runtime and the deployment time entities, and we kind of strive towards the least privilege methods. And wherever there is a broader roles, we kind of created custom roles, and we kind of made sure that all the agent environments get the least privilege roles. So that was the second. And one more is tooling. So tooling is a kind of a new concept for agentic environment. So what we did was kind of restricted tooling from the platform side itself. So suppose there is an agent which is running and answering customer questions, right? What we did was we didn't allow that agent to have multiple permissions around payment or customer data, so that even if the environment is compromised, it doesn't give a bad responses. So that's how these are some of the major considerations.
Got it. And then can you share an example where deploy time permissions were different from runtime permissions and why that was important to you?
Sure. So I would like to give one example where specifically security team got involved. So there are two things here. One is a deployment time entity and one is a runtime entity. So we had a requirement wherein our agents needs to connect to some of the services on our VPC. But the problem is, while creating agents, the service agents were involved, but at runtime, there's a separate service accounts were involved. So we granted this DNS peering permissions only to the deployment type entities so that they can create the peerings, and that was acceptable. But we made sure that DNS peer permission doesn't get to the runtime entity. So just imagine runtime entity has a DNS peer permission, and it start accessing your internal services. That's a big mess. So that's how kind of separated the entities and the permission models.
Got it. Yeah. No, that sounds fascinating. It's really good to see that the stuff that we're building, sort of you're putting it in action, you're testing it, and your feedback has been tremendously valuable through the journey as well. So if with this in mind, what is the next step in your journey? Where do you want to take it?
So as you said, right, the agent gateway, right, the agent registry, those are inbuilt features you are providing. Those are great features. They're going to help us a lot. We don't have to manage them ourselves, like the way we are doing Cloud SQL. So basically, what we are doing is to reach to our agents, we are using an external load balancer. So we have to put a lot of guardrails around that load balancer. Now with the agent gateway, our job will be very easy. Okay, and that's both ways, right? Ingress to the agents and egress to the agents. It's going to solve our issues, so it's going to help a lot. So, yeah.
Awesome.
And last question, what's next for agents at Best Buy? And what are you excited about with the agents that you're building?
Yeah, for sure. So we want to onboard the agents onto the Vertex AI itself, and that's our journey. And we have a lot of things in roadmap. So for example, here, if you see the example here, right, there is a question with the intent here from customer for asking the headphones, and we have given the headphones here. But the security around the tooling, the amount of access it needs to have, we want to bring in the MCP server, we want to bring in the model armor to protect our models itself, put in some service controls to put some restrictions around the Google APIs. So these are our things on the roadmap, so yeah.
Fantastic. So thank you so much, Kishor, for joining us on stage and sharing your journey. Hopefully this was useful for you as well. And you can take some of these learnings maybe to your enterprise as well.